Hello, we're going to look at specification point 1c, atomic structure. First thing we're going to do is look at what the difference is between an atom and a molecule. So an atom is defined as the smallest part of an element that can exist. And this is really the smallest part that can take part in chemical reactions. Second thing to look at is what a molecule is, and that's a group of two or more atoms that are bonded together. And these atoms can be the same types of atoms or they can be different types of atoms. So a couple of examples. Oxygen gas is made up of two oxygen atoms joined together, and that's a molecule. And water, H2O, is a molecule made of hydrogen and oxygen atoms. So it's made up of two hydrogen atoms and one oxygen atom. I'm now going to look at the structure of an atom. And we're going to look at where the different parts of the atom are found within the atom. And the different parts within the atom are called protons, neutrons, and electrons. These are also referred to as subatomic particles. So we're going to look at each one in turn and where they're found within the atom. So the first thing to look at are the protons, and these are found within the nucleus. We also need to know what charge they have and what relative mass they have, and these are things you have to learn. So protons, clues in the name, are positive. You need to know that they have a charge of +1, and we give them a mass of 1. And it's a relative mass because it's not the actual mass of a proton, so it's relative to other things. So it's got a relative mass of 1. Neutrons are also found in the nucleus, but this time they have a charge of 0, and they have, similar to a proton, a relative mass of 1. And electrons, they are found in shells surrounding the nucleus, and they have a charge of -1, and you also need to know the mass. They're really, really tiny. They have a relative mass of 1/1836. Anything in that sort of ballpark will get you the mark, but you do need to know both the charges and the masses of these different subatomic particles. And what you should notice there is that nearly all of the mass of an atom comes from the protons and neutrons. Now we're going to look at what the difference is between atomic number and mass number. So the atomic number is the number of protons that an element has. Every element has a different number of protons, therefore every element has a different atomic number. Mass number is simply the number of protons plus the number of neutrons, and I want to just show you how this works in practice on the periodic table. So if we choose the element phosphorus, phosphorus has this symbol. It's got an atomic number of 16 and a mass number of 31. Now if you remember, the atomic number is the number of protons, so therefore it has 16 protons. Mass number is 31, and remember, mass number is made up of protons and neutrons. So if we want to work out how many neutrons it has, we simply do 31, or the mass number, minus the number of protons, which is 16, and therefore it has 15 neutrons. So that's how you work out how many neutrons an atom has. And also, we haven't done this yet, but if an atom has 16 protons, it will also have 16 electrons. Next one we're going to look at is isotopes, and that's a really common source of exam questions. They do like to ask about isotopes. So isotopes, and you need to learn this definition, they're atoms of the same element with the same number of protons but different numbers of neutrons. So that means effectively that they have the same atomic number but they will have different mass numbers. And a good example here, there's loads and loads and loads of examples, is carbon-12 and carbon-14. So carbon must have an atomic number of 6. So both isotopes have to have an atomic number of 6. One has a mass number of 12, one has a mass number of 14. Just to recap from the previous slide, that means both of them have 6 protons. The difference is how many neutrons they have. And remember, to work out the number of neutrons, we do the mass number, 12, minus the atomic number. So it's got 6 neutrons in this isotope. And the other isotope is 14 minus 6. It has 8 neutrons. Right, the last thing we're going to look at is the relative atomic mass. This is often the number that's quoted in the periodic table in place of the mass number. So it's relative atomic mass and it's given the symbol AR. So the definition is the weighted average mass of an element's isotopes. Essentially what you're doing there is looking at all of the different isotopes of one particular element and averaging the mass of all of those put together. And there's two factors to that. So there's the mass of the isotope and there's the abundance of that particular isotope. And what we're going to do as an example is calculate the relative atomic mass of chlorine. And this is a really, really common exam question. So I'll show you how to do it for this particular example. So we have chlorine 35 and we've got chlorine 37. So two different isotopes, and the number next to it is a percentage. So that is what we call the percentage abundance. So if I was to take 100 atoms of chlorine, 75 of them would have a mass of 35 and 25 would have a mass of 37. So how do we calculate what's known as the weighted average mass? So there is a formula, and I'm just going to show you how to do that. If you do it for every single one of these, you'll get full marks. So what we're going to do is take the mass number of the first isotope, which is 35, and you're going to multiply by the percentage. And they will always give you the percentage. You're going to put that in brackets, and then you're going to add, in another brackets, the mass number of the other isotope, 37, times by its relative abundance, which is 25%. And you're going to put all of that over 100 because it's a percentage. And if you plug those numbers into your calculator, and I would suggest you maybe break it down into the two separate parts, do the top line and then do the divide by 100, you should get an answer of 35.5. Now, quite often they want the answer to one decimal place, but read the question carefully, and I would suggest you highlight if they do ask for that. So this is to one decimal place, 35.5. Another quick check to see if you're in the right ballpark. You've got two isotopes, 135, 137. Your average mass should be between 35 and 37. So that's a quick check you can do to make sure you've done this correct. This is a really, really common exam question, so good source of marks.